Hello. Today I will be discussing about the regression analysis. This is the second part, and you can find more detail in this lecture. So, so this is the regression equation where y is the independent variable, y is the dependent variable, and x is the independent variable, and this is the error term, the disturbance term, and this is the intercept term, and this is the coefficient. This is the deterministic part, this is the deterministic part of this equation, and this is the error part of the stochastic part. Okay, so so this is the regression equation or stochastic relationship, and here one thing you should remember that the some assumptions are there regarding UI. Some assumptions are there. What are those assumptions? That mean that is the expectation of UI is zero. That is the average of error or is zero. So, and the variance of UI, that means the variance of error is constant. It is constant, sigma square. It is constant, and UI and UZ are independent for all I and Z. Okay, so it means the error in period 1 and error in period 2 are independent. Error in period 1 does not have any relation with the error in period 2. That is, if you have some disturbance in 2000, then and the error in 2001, the error in 2000 and error in 2001 does not have any relation. And another assumption is the normality. Normality means the error or disturbances are normally distributed. That is the zero mean and constant variance. Okay, so if you consider this is the um, income, and actually in another way we can consider that if we consider that this is this is saving, y is the saving, and this is the income. Okay, if if we have a pictorial representation, then we can understand what is the u, what is the error. Okay, so look at this picture. This is the this is the this is the y-axis, and along this y-axis we measure the savings, and this is the x-axis we measure the income. So so income is the independent variable, and savings is the dependent variable. Okay, as income increases, you can have a closer look in this picture that as and this represents the density. The density, it represents the density. Okay, so if you have a closer look that at xi, suppose in this income x1, suppose in this income the savings is normally distributed. That is, it is the variance is constant. Look, variance is normally distributed, and variance you can find that in case of x2 income, the same variance is there. The same variance is there. Okay, in the same way, in case of income x3, then variance is same. This variance in y, that means this variance in savings is due to the error term, the disturbance term, and this is normally distributed, and constant variance are there. Okay, so this is the constant variance. You can say homoscedasticity in this case, and and if you look the second picture, you can find in the same the income and savings, and income is the independent variable, and saving is the dependent variable. Then you can find and x1 there is the variance in y due to disturbance term is not same with the variance in y in x2 income and and in x3 income the variance is not same with the variance of x2 income in and variance in x1 income. So variance differs here. You can have a clear pictorial representation that you can find that the variance is clearly not constant. So so this is the heteroscedasticity, and this is the heteroscedastic. So so this is due to the error term, as I have mentioned in this slide that mm, you can find this is due to the due to u. Okay, so so now now look. So since expectation of u is constant here, expectation of u is constant here. So this is the population regression. This is the population regression, and putting the value of the parameters alpha and beta, we get simple regression function. If we put the value of alpha and beta, we can get the simple regression function. Okay, so now there are three methods. There are three methods for estimating the parameters. There are three methods. One parameters means alpha and beta. That is the intercept coefficient, and this is the slope coefficient. Okay, the method of moments and the method of least squares. The method of maximum likelihood. There are three methods. By using these three methods, we can find the value of alpha and beta. So in my next lectures, I will discuss about the method of moments, the method of least squares, and method of maximum likelihood. So this is a part of my lecture on regression analysis. So I hope you can have an idea over the error term, the disturbance term, and and here one thing I should mention that look, the variance is as income increases, the variances in savings, variance in savings mm, are, are not uh, clustered in in a particular place. Here here is a cluster you can find the you can find, but here it has spread. It has spread it. Okay, here it has spread it because as income increases, as income increases, there are more scope for savings. There are various ways to save. So so the variance is flatter here, and here you can find the variance is not flat here because when income is low, the savings is there is minimum option to get your income set. Okay, so so this represents such type of situation, but in this case, as income increases, the variance are same. So this is the homoscedastic, and the arrow is homoscedastic here, and here it is the heteroscedastic. So so I hope you have understood the regression analysis and the savings and the error, especially the error part in this lecture. So thank you for enjoying this